I think we are live. Hello, everyone. Good evening to everyone joining from India, and good time to everyone joining from other places. If you have anyone from outside India, give us a quick heads up if you can see us and hear us in the chat section. Okay, perfect. Sandeep and Swapnil has done the job. Okay, we are good to start. Let me just push a live button on Facebook. Yep, it's done. So, good evening, everyone, again. Thank you for joining on a Saturday evening. And this is yet another episode of Tribecast webinar. I think we have done many so far. And we have yet again Robert Sabourin, and RobSab is the easy short form for me. Since the time I met Rob, I have formed a very special bond with him. And I'm sure as you interact more and as you learn more from him, you will feel the same as well. While we have done a webinar before, and we are going to do a just-in-time testing boot camp as well in the coming months. I will like Rob to introduce him again when he starts, when I hand it over to him, because I always find his introduction quite fascinating. The things he have done in his 38 years of career, that is even the small portion of that, or small part of that, we nowadays at times get scared of it, like what it is and how we will do it. But yeah, 38 years speaks a lot. So on that note, I'll hand it over to Rob, and we
Perfect.
should be good to start.
All right. So may I start?
Yes, please.
All right. Well, thank you very much. And it's an honor to be invited back. And what I love about today's webinar and what really excites me about this is that it's based on questions we had in a previous webinar. And I just love that because I measure success in my presentations by the questions that come from it. And I learn so much from the questions and the concerns people have, and it's wonderful. So my name is Rob Sabourin. I've been involved in software engineering for a long time. I mean, it's the dawn of time. Wrote code when I was 12 years old in the early 1970s. My first commercial release was the Quarto graphics package released. It's a windowing system released on June the 4th, 1982. And so when you talk about 39 years, not 38, 39 years now, that's just commercial. If you go back to 1972, that's 49 years of programming. So it's hard to believe I've been involved in it so long. But yet my grandchildren today are learning programming and learning these cool things about using technology. So I think it's just sort of fantastic to have a life in this domain. I've seen and witnessed so many changes, and I've evolved with it. I've done many commercial releases of many software from many perspectives. My passion, as you might know, is software testing as part of software development, but I'm a huge fan of really working on helping to identify and improve the skills of testers individually and the collaboration skills of people in the software engineering process. So I consult and I teach. Right now, my teaching is at McGill University, plus I professionally teach. I go to companies. I do all sorts of stuff like that. So I'm happy to share my experiences. And the question that I was asked was, about learning programming languages. And I advocate so much. I advocate to people, don't get locked in. Don't get locked in to a specific technology. The technologies will change. I almost can guarantee you that if I did this talk in 1 year from now, that we'd be talking about dramatically different technologies. And in 2 years, it'll be like science fiction. You're not going to really recognize things. So what I try to do is sort of say, learn how to learn new technologies, learn how to adapt, learn how to apply your skills, experience, knowledge, wisdom to new problems. When I try to sort of help and advise people about roles and responsibilities today in software engineering, I end up with this whole thing of what are the skills we need to start hiring testers and stuff. And so many human resources departments go and they make this list of things like we need someone who knows Java programming language, we need someone who knows REST API, we need someone who knows microservice architecture, and then they say specific tools. We need someone who knows this tool, that tool, the other tool. All of these things come there, and you look at that, and sort of people say, hey, to get a job, I have to tick off all these lists, otherwise they're not even going to interview me. And I'm looking at this, and I sort of say, wow, that's bizarre, because the knowledge of a tool could be, very, very cosmetic. It could be rote. You could have memorized how to write a certain type of program or something, or you could have done enough to pass some sort of certification test. What I look at is what can you do? What can you do? Not really. Do you know the tool? I could know a programming language and I could master it to the point of architecture of complex systems, or I can use it to print a little hello world message on the screen. Do I know it or not? What is the depth of knowledge needed? That's very, very vague today. Now, when I'm talking about learning languages, I've learned so many, and the type of language we're going to talk about today are scripting language. Scripting languages are non-compiled. So they're programming languages that are interpreted, not compiled, which means that to use a scripting language, you do not need an IDE. You do not need an integrated development environment. So you can just take a text file, literally a notepad file, text file, and put your script in it, and then you run a program to install a scripting environment on your computer. Usually involves just copying like one file over, and you don't have to get all sorts of fancy things together to do it. So scripting for me is a very graceful way to, I guess, automate some parts of my work. And it's light, easy to do, not a lot of setup, but the languages change a lot and they evolve. And so I've learned a lot of them over the years. I started off in scripting, I guess, before I even went to school. I learned bizarre scripting from the IBM mainframe environment. Weird scripting. JCL, they used to call it, job control language scripting. And I learned enough scripting to get my job done, but it was really obtuse scripting, and models were bizarre, syntactically weird. Anyhow, then I moved on to learning scripting on proprietary operating systems, mostly of Digital Equipment Corporation, RSX, RT11, TSX, VMS, all these operating systems. And each one had their own scripting languages. And then I moved on to Unix, the world of Unix, and I ran into graceful scripting languages, shell scripts, Bourne shell, Corn shell, C shell, all these shell scripting languages. And moving on then to processing languages, which the early ones, Lex, Awk, Yak, all those are old scripting languages. They're still used in the world of Unix and Linux and all that stuff. Then I moved on to languages that were more powerful, like Awk. There was Awk, you can do a lot of stuff you couldn't do with the basic shell script. And Awk was, though, really obtuse. Like, no one could read your script and understand it. And so I moved from there to Perl scripts. And Perl scripts were great and powerful and wonderful, but still hard to read and interpret. And then I moved from Perl to Ruby. And recently I'm dabbling with and working with Python. And I've mucked with all sorts of scripting. I'm mucking with JavaScript a little bit on the side. But I basically have learned how to learn new scripting languages. And I don't sort of get attached to any one of them. And so I wanted to share a little bit today on a systematic approach I use to learn new scripting languages. So learning new scripting languages, a sort of systematic approach. But this is how I do it, how I have learned and continue to learn new scripting languages. And I tested the presentation on a scripting language while I was doing the presentation to make sure. And the language that I was mucking with was Python. I already knew a little bit about Python, but I'm far from a master of Python. And I've got customers who just love to use Python. So I like to be conversant in Python. But also I want to do really useful stuff, like scripting stuff that's really, really useful in my exploratory testing. So I basically built an example. I hope to show it to you today. And I'll share with you the source code of anything I show you today. I'll make it available to you. I'll make sure that I give the links to the testing tribe so we can share the slides, the examples, the source code. I've got a couple of example scripts I made just for today. So moving on, click. I broke it down into steps. And these steps, frankly, I had to do it to see what are the steps. And the first few steps are what I would call the basis. They're preparatory. They're really the kernel of knowledge that I think is fundamental to learn, or for me to learn, new programming languages or new scripting languages. So without these, I don't have a basis. I don't have a basis to build on. So I want to start with basically a few of these basis things. And the first one, the very, very first one, very, very fundamental, is before you start diving in and trying to learn JavaScript in 21 days or whatever, or Python in a 2-hour lecture or some tool in a webinar, take time to understand what I consider is important is the basic computer model. What is a computer? What is the basic computer model? And I've run into people who really, really learn scripting languages without understanding the basic computer model, and they can't take their skills and apply them easily to other places and other things. But if you have a sort of notion of what is a basic computing model, then you can sort of build on it. So what is my basic computer model? And you can have a different one or a simple one. The level of abstraction, the level of complexity is really up to you, and it might evolve with time. But still, for me, it's very important to have it. So I start, and the model I use is very simple. I learned it when I was quite young, and it is still called the von Neumann computing model. This is from a guy called John von Neumann, who as early as 1945 published the fundamental model for a computing which is still used today. In fact, almost every digital computer that you could see, acquire, or use today uses the von Neumann model. So this model, for me, stands the test of time. It's fantastic. And just to get you to one of the first people to be inspired by this model is a guy called Alan Turing. So if you want to sort of go back and say, where did Turing get the ideas from? Von Neumann made it so simple and so clear. His model is almost trivial, and trivial to the point that some people discount it as naive, but it's not naive. It's far from naive. It's actually, in its day, it was brilliant. It was an innovation in thinking. And I think that everybody who's involved in computing, who wants to learn language, should sort of take a look at this model to start with. So the von Neumann computing model is basically very simple. There is a model of something called a processor and something called storage, and that's pretty much it. Processor and storage. Storage is memory, right? Storage includes both program instructions and data. This was the huge revolution in computing, is that, wow, the same computer memory has your program and your data. It's not two separate things. It's not two different universes. They're in the same place. They are the same thing. Actually, a program is just data in memory that's interpreted by a processor. And that's it. And if you can wrap yourself around this, you start understanding a lot about computing. It's just a processor that goes there and retrieves instructions from memory. It goes and gets some data from memory. It reads it, interprets it, and does something with it. And it basically goes to the next instruction. And that's what it is. So we store data and instructions in the same memory. That's the von Neumann model. The processor receives instructions and executes them from memory, the same memory that it's putting its data. It stores data in memory, right? And it retrieves data from memory. So that's the von Neumann model. It's so simple. And visually, I look at it with this little simple diagram. So you have a processor, you grab stuff from memory, and then, of course, it can also talk to the rest of the world. So you have input and output. And if I go and I say, if I'm going to learn a new scripting language, I sort of got to understand that the processor is going to get instructions from memory. And the memory is going to have the data I have and the instructions. The instructions are basically what my script is all about. Ultimately, my scripts are instructions that are going to be interpreted by the processor. Now, you can go through levels and you can say, well, okay, so the script is interpreted, the interpreter is a program, the program is a processor. You get different levels of virtualization, but it's all comes down to a simple model. And so I start by saying, this is an important thing. You've got to grok this model. And I don't think it doesn't have to take years or hours to do. It can take a few minutes, but it's really important to grasp that. The program that is going to be executed is in memory, and it's the same darn memory that you're putting things in. It's the same darn memory that you're taking things from. It is memory, what they used to call storage. And there's lots of technologies that are going to change, but it's always this basic, for me, this same model. I start with this very simple model. Now, knowing that model helps me. So I want to say that, where do you start? That's what I start with. I have a model of what is computing. Remember, I'm trying to talk about learning a scripting language here. So I may not have ever seen or heard the scripting language. And some people get so caught up in syntax of a scripting language. And well, yeah, there's syntax issues in scripting languages, but that's not learning the language. The syntax, you can figure it out and don't memorize the syntax. That would be almost foolish to do, in my opinion. What I do is look it up when you need it. Get a good reference book. I mean, I got reference books and all sorts of technologies, and I'll look it up. I don't need to memorize the syntax, but I need to understand the models, and I really need to live with that. The second thing, so before you start trying to learn a new programming language, learn a new technology, learn a new scripting language, I think it's important, and for me it's important, to master logic and Boolean algebra. And the word I use there is master. And this is now, I'm not talking about just knowing here. I'm talking about mastering. And there's very simple concepts here. It does not, again, it's not a lifetime of learning to master logic and Boolean algebra. You have to be a clear thinker to learn this, but you don't have to have a master's degree in mathematics or anything to do it. But you do, I believe, have to really understand logic and Boolean algebra before you can start trying to learn programming languages or scripting languages. And I tried to figure out what would I say is a good amount of time to invest in this to master it. I think a dedicated afternoon is a good starting point, and I think you should always have a refresher of this. You might want to sort of put it all in an index card and stick it on your wall or something just to remember it. But it's not something that you have to take long courses in. Now you can dive in deep to understand the history of logic and clever things you can do with it. But I think logic is fundamental. If we didn't have logic, we wouldn't have computing. We wouldn't need computing if we didn't have to make logical decisions about things. So logic fits in several ways into everything you're going to do with your computer, no matter what programming language or technology, no matter what vertical domain you're in, no matter what you're going to do. If you're going to be a tester, frankly, you should master logic and Boolean algebra. And I don't want to promote or self-promote myself, but I have actually a whole course just dedicated to the subject of fundamentals, testing fundamentals for experienced testers. And I run into a lot of people who have been testing a long time, and they never took the time. They never took an afternoon off to try to say, hey, let me just master logic. Let me really become very, very good at logic. So what is logic? Well, there's two types of logic I'm going to talk about. If you go onto the internet, you're going to find there's dozens and dozens of types of logic. But the two types I want to talk about are Aristotelian logic and Boolean logic. So now you get me, Rob Sabourin. I'm going back to 380 BC and Aristotle. And I'm going to tell you that that is important. And that has a lot to do with scripting. Aristotelian logic has to do with basically what are called syllogisms. And they're basically, if you look at code ever, you're going to see these statements called if. You're going to see statements saying if, then, else. If this, do that. Otherwise, do something else. There's decisions. If we didn't have decisions in our software, we wouldn't need to have software. There is no value in software without the ability to sort of make a decision. And the idea of instructing a computer means you can somehow express those decisions. And so this is where Aristotelian logic helps us. And it's basically what we call syllogisms. And the basic idea is quite straightforward. Like I'll just give you an example. Here's an example of Aristotelian logic. So you start with the idea. There's a premise. This is all humans are mortal. All humans are mortal. Then there's another premise. All Greeks are human. So you talking about Aristotle, ancient Greece. So all humans are mortal. All Greeks are human. Therefore, all Greeks are mortal. So this is logic. This is Aristotelian logic. It is not complex, and some people would say it's obvious. Maybe obvious, but still learning how to express it, learning how to express your thoughts in terms of syllogisms will help you understand, given this precondition, when this event happens, then this variable outcome takes place. That what I just said is Aristotelian logic, and it's called Gherkin, and it's used in the tool Cucumber. And it's just an implementation of something from 380 BCE. This is not new. It is not a new concept, and it's beautiful. And some people put it in the realm of philosophy. Well, for me, it's just important as someone who's going to learn a programming language or a scripting language, understand the basic Aristotelian logic. That's all. It's basic stuff. You know, all humans are mortal. All Greeks are human. Therefore, all Greeks are mortal is logic. And so if we can understand that type of logic, and they're called syllogisms, it does take a little while to learn it, but I'm saying hours, not months or days. And it's beautiful. I don't think you have to know the whole history of it. I love the history of it, by the way, and I love the misinterpretation of it, and I love to play with it because there's really cool things you can do. Like you can say things like, all my grandsons are doctors, and I have no grandsons. So is that statement true? And you have all these interesting things because suddenly you said, well, what if there's an empty set there? Then you get to think, oh, wow, this is a really crazy condition. What you're doing is you're thinking of logical conditions that your program has to take care of before you even got to programming. So if you can represent things logically, you can then sort of express things that can be programmed. So that's the beginning, Aristotelian logic. But that's not enough, right? I mean, that's nice. It's fun. You can talk to your philosophy friends. You can imagine going to a pub and spending hours talking about Aristotelian logic. To be practical, though, we need to dive into the realm of Boolean logic. And Boolean logic is the binary logic of circuits and computers, and it's basically what makes modern electronics tick. Boolean logic. Boolean logic comes from the beautiful, beautiful work of the mathematician George Boole in the 1800s, and he found beautiful ways to express logic and looking at statements of logic based on truth. So Boolean logic is the logic of truth, And computers are based on truth. Isn't that beautiful when you start seeing if computers are based on truth? It's sort of almost suggesting that it's all about honesty here. Well, it's not honesty, it's truth. And this is basically beautiful work that Boole did. And he came up with basically logic operations on variables which reflect truthfulness. So a variable in your universe, something that can change. The state of something. So basically, are you logged in or not? It's true or false. So the variables here are reflecting truth. So they can be true or false. And there's only so many operations, the basic operations that you can do on on Boolean variables. And it doesn't, again, take a long time to master this, but I do believe that you should be very, very good at understanding, synthesizing, and creating expressions using Boolean logic. So the basic operations are and or not. That's it, and or not. So if you have two variables, you can say logical variable x and logical variable y, x and y. You can say logical variable x, logical variable y, x or y. And you can say also logical variable x and not x. So if something is true, not true is false, right? If you say, I don't know, I woke up this morning and I'm doing a seminar. So there's two things. Did you wake up or not? True, false. Are you doing a seminar? True, false. And so and is I woke up and I'm doing it. So that's true, true. True and true is true. And then if you have true and false, false and true, or false and false, it's always false. And this is just basic Boolean algebra. The logic of truth, and the logic of truth is simply expressed. So in computing, we depend on Boolean algebra. I don't think it's really possible for you to find a computer program that does not use basic computer Boolean algebra somewhere. Logical expressions. So this is true and something else is true, or one or the other is true. So I woke up or I'm doing a seminar. I woke up is true. I did not doing a seminar. So both of them, when you or it, it's true. 0, 1, that's false. True is going to always be true. True, true is always true. So that's or. And not is opposite. So these are basically Boolean constructs. We can get abstract a little bit, but you don't have to get too fancy. There's some key things I'd like you to know. I'd like you to learn. And you can learn a lot of it by watching the beautiful animation from Warner Brothers called Bugs Bunny. I don't know if you're familiar with Bugs Bunny, but if you want to go watch Bugs Bunny and look at the writing of Bugs Bunny, the authors of the Bugs Bunny cartoons used Boolean algebra to write the cartoons. And if you watch the cartoons, they're all beautiful expressions of logic. And for example, there's a very famous scene, and this might be culturally unique to North America, I don't know, but there's a guy called Elmer Fudd. He's a hunter, and he's hunting, and he wants to hunt for a duck, but he doesn't know, is it allowed to hunt ducks or rabbits? So is it rabbit season or duck season? And Bugs Bunny, the rabbit, is always trying to trick him into shooting Daffy Duck. And there's this sort of logic always going on. Should you shoot the rabbit or not? And if you look at the humor, what they're doing is they're teasing you, they're playing with you. And what they're doing is playing with Boolean algebra because they're looking at opposites, what I call funny opposites. So if Daffy Duck says, you don't have to shoot me. I demand that you shoot me. Shoot me now. There's all these things that happen. And it's because they're twisting the opposites. So they're twisting the opposites. And when there's two variables, the opposite of an and of two variables is called a nor, actually. So we got the opposites are things that are funny. So if you say something is, what is the expression here? If I can say true, what's the opposite of A and B? So let's say the expression A and B. What's the opposite of A and B? It's not A or B. And so there's three opposites. And now I saw this so much in testing. It's crazy. People are testing something and they have a condition. They have like a business rule in insurance that says, okay, if someone lives in Canada and they're over 30 years old, so they have to test the business rule about that. Well, there's four possibilities, right? Four possibilities, not one possibility or two. There's four possibilities. True, 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 false, false, true, false, false. Now, if you test that and you say, okay, I'm going to do one positive and one negative test, well, the positive test is true, true, and the negative test is you pick one of the three you want. You're missing, if you just do one negative test, you're missing two of them. And this comes from Boolean logic. You'll see clearly that you have to do three tests to test the opposite. So you do one test to test the affirmative, that's for two conditions, and three tests to test the negatives. And if you have 3 variables, A and B and C, then there's 8 possibilities. 1 is true, 7 are false. So this is called De Morgan's rule, but what I'm expressing to you becomes obvious and clear and crisp if you understand the basis of Boolean algebra. Also, if you start studying it, you'll find this interesting operator called not and. So that's NAND. So it's basically the opposite of A and B. And NAND, if you can express NAND, you can express any logical expression by just having that operator NAND. And the earliest computer circuits implemented what are called NAND gates, which are little transistor circuits that did this not and thing. And you can make any logical construction with one little baby digital circuit. And that's sort of, for me, so cool. But to understand that and to get excited about it, you got to dive in and learn some Boolean algebra. I don't think you should even try to learn a new scripting language until you've really learned Boolean algebra. And I don't think it's a huge investment to do it. It's, once you're comfortable, maybe working with a buddy, in a half a day, I'm sure you can learn all sorts of stuff about it and then practice a bit as you go. But it's not complicated. Boolean algebra is not complicated. And yet it's people, of course, study it abstractly, but it's the basic operations. It's like going back to school and learning your counting again. They should teach this in grade 1 and grade 2. It's something you should learn and always know it and master it, like know it by intuition almost after a while. So that's the first 2. So we got logic, computing model, and logic. The third thing, describing the steps to do things, what I call the concept of control flow. Now, control flow is basically, for me, visual. I want to draw a picture of the way I want to solve a problem. Now, when I'm writing a script, I'm trying to solve a problem of some sort. So I want to say, what are the steps you need to do to solve the problem? And I, Robert Sabourin, visualize that. I'm a big visual model person, and personally, I like to use what are called control flow diagrams or flow charts. And flow charting is the basic way to do it. So before I write a script, I will always write some sort of a diagram, draw a diagram. It can be by hand, it could be with tools, but it's basically a representation of the steps required to solve the problem. And again, I'm going to get back to basics. This is fundamental. There's only four basic things you have to learn about flowcharts. 4 basic types of steps. So there's the termination step. That's the beginning and end. A process step. We're gonna do a calculation or something. So it's a process step. We're gonna do an action. That's a process step. Decision. That's your Aristotelian and Boolean logic. You're gonna make decisions. And input and output. Programs are useless unless you can get things in and tell people what happens. So you need to have model and have a step for input and output. Those are the 4 basic flowchart symbols. The 4 elements of describing a process. If you want to look at the most fancy, sophisticated process modeling technologies in the world, what it comes down to is they gracefully let you manipulate these 4 concepts, the 4 simple concepts. So this is the basic flowchart symbols. Now, this is a flowchart. I actually constructed this flowchart in preparation of this workshop to create a script. So before I write my script, I basically create a flowchart which describes step by step what I want the script to do. It is at the level of granularity that I have here. The tool I used here, I used something called Drawio, which is a beautiful technology. It's available for free online. Very, very easy to use. And you'll see this is a little script here. So I put it just so you can view it at a zoom that's probably a little bit too big. Let me just move it down to 125. So if you start off here, so you see there's a terminator, it starts. Then I have a sort of this is just steps. So I have a variable called over. I set it to false, so we're not over. Then in this script, what is the script doing? Well, the script here is doing keyword-driven test automation. I whip it off. I've been doing these, I can do these things, many, many different technologies, but it's, for me, a basic fundamental pattern in scripting using keyword-driven test automation. And I basically put blocks for the processing steps. So create an output repository. That might be 5 or 6 steps in a script, maybe 10 or 20, but that's what I'm doing. So I create a repository. Where's the output going to be? I have some error handling in case that fails. I put the manifest. That's my interpreted data. I put it in the repository. Then I open it, and then I read through it one line at a time. I get one record at a time. I read the record. Am I finished? No. Okay. Process the record. This is just processing the record. That's the processing the record. And then when it's finished, it closes and it ends. And as we go, I log the results. So this, you'll see, I put a copy of this. I'll share it with you. You can go through it, but it's basically one simple page. In North America, we'd say that fits on an 8.5 by 11 piece of paper. Let me go back to PowerPoint here. Slideshow from current slide. It's funny, it doesn't seem to be sharing my slides. Where's the... Very strange. All right.
Yeah, we can see the PPT, Rob.
You can see it?
Yeah.
Can you see the slides?
Yep.
Okay, it's just gone funny. Anyhow, I try to get the flowchart on one page. Now, where do you learn how to do this? All right. I learned how to do this, started to do this when I was in school, probably around the same time I started learning about computers. And our teacher basically said to us, okay, how do you tie skates? Now, maybe in India, you don't tie skates too often. I don't know. But in Canada, this was a very big thing. And as a child, we had to know how to tie our skates. If you didn't tie your skates right, the skates would basically fall off or you'd twist your ankles or something. So the teacher asked us to write the instructions, write down the steps, how to tie skates. And then what she did was she had people in the class follow the instructions. And it was hilarious to watch people trying to follow the instructions for tying your skates, because everyone was doing silly things. Because computers take things very literally. And when you follow instructions, you take them literally, you actually might say, whoa, I missed a step or something went wrong. So the thing is, when you're trying to draw your flowchart, you walk through it and you basically interpret it as if you were just basically like a computer, and you do exactly what it says. And you might find that you're missing a step or that what you're saying is ambiguous. And so you clean it up and you refine it until you get it right. Another one I do all the time nowadays is I ask people to describe how to make a peanut butter sandwiches. And I do this actually in formal task analysis with companies. I ask them to describe how do you make a peanut butter sandwich. And you wouldn't believe how hard it is for people who have never thought of process modeling to write the steps of doing this. So if you cannot describe how to make a peanut butter sandwich to someone and have them follow the instructions, you're probably not ready to start learning a scripting language. And I'm not suggesting here that you don't have the skill. I'm saying you got to learn how to describe things in steps. That's control flow. I visualize it with flowcharts, but visualize it anyway. And you can use what's called pseudocode or abstract layers or fancy tools. There's lots of ways you can draw this. There's object modeling. There's a UML. There's all sorts of ways you can draw it. But still, you have to be able to describe the steps to solve a problem. If you can't do that, you're jumping the gun when you're trying to make your script. So you got to basically understand how to solve a problem step by step and to describe it. My favorite way visually is with a flowchart using open source tools. And once I've got my flowchart, I walk through it, I make sure it's clean. I even might get a peer to take a look and say, hey, Rob, does this make any sense? And read through it and interpret it. And if, of course, they might look and say, well, Rob, you missed some of these funny opposites, or, yeah, that's pretty clear. So I try to get it expressed in a way that is clear. And then once I've got it expressed, then I can start making my script. So that's something you got to learn how to do that. The next step, modeling input and output. This is a simple one. every scripting language, so now you're starting to look at a specific scripting language. Remember von Neumann model, there's input and output. Every scripting language has a different way to manage input and output. I try to stick to learning things, starting with the question of, okay, where do we get input from and where does output go? And, I run into every scripting language has a sort of nuance here. The basic idea is there's some sort of path of input and there's some sort of path of output. And if there's an exception, there's some sort of path that we can log error conditions. And how this works varies dramatically across different scripting technologies. So there you've got to go and you've got to look and say, okay, let's say you're trying to learn JavaScript. So in JavaScript, how do you read something in? How does it read something in? And really ask that question. Don't ask questions. How do I create a script that does fancy stuff? Look at the fundamental things. How do I get input? And then ask the other questions. How do I give output? And in JavaScript, it's very different from Python. JavaScript is actually building web pages or constructs around web pages, whereas Python is a stream model. So you got to look at how these things work, and this varies from scripting language to scripting language. But still, I don't want to start diving in until I start building knowledge of how things move in and move out. Now, luckily today, there's great resources on the web to do that, and you could probably find for any scripting language a how-to video on YouTube that you can walk through, and within an hour or so, you will learn the basics of input and output for the programming language or for the scripting language. So for me, this is an important concept. If I don't know how to get things in or put things out, I'm not going to be able to do anything practical with this language. So if you want to know what do I learn first, how to get something in, I use the word read, how to get something in, and how to write, how to get something out. And I try to learn that. And this is intriguing. It's not always as trivial as it might sound, but it's also, once you've learned it, that applies to every script you're ever going to write forever and for always. So this is something that's pervasive. It's forever and for always. So that's my step 4. So now everything before this, right, was the foundational stuff. Now we're getting into language dependencies. So to learn a script, I learned input and output. And I could show you different examples of that. I'll show you one script towards the end here. Second step, so input and output, I learned how do I get things in and get things out. It doesn't have to be complicated, but it does vary. It's not the same in every scripting language. Just because you know how to do it in Ruby doesn't mean you know how to do it in Python. Doesn't mean you know how to do it in JavaScript. Doesn't mean you know how to do it in Unix scripting languages. You really have to go down to the individual language and learn about input and output. Next, there's the concept of variables. So this is like my step 5, the notion of variables. Now, to vary, right, is to change. To vary is to change. And variables in scripts, variables are ways we represent in memory. Remember the model? We have memory storage, right? Things that can change. So we have program variables. We represent in these variables things that can change. So I want to learn for my programming language, how do I store variables? But I don't have to get fancy. A lot of people sort of start looking at complex object models and really tricky, weird names of variables. But there's basically 5 types of variables that I seem to use a lot in my scripts. And the first 2 are the basic ones. So text, representing textual information. A lot of what I read and write is text. A lot of what I manipulate is text. So basically, things are constructed with text. Text is the basic building block for stuff like HTML and XML, or JSON. So text I start with. So I learn how do we have text variables? How do they work? Then numbers and basic whole numbers, like counting numbers like 1, 2, 3, but also decimal numbers like 12.75. And complex numbers, if you're into math, complex numbers are a type of numbers we use in engineering a lot, which have vectors, 2 dimensions, so real and imaginary dimensions. So I look at and I learn how are numbers stored in variables, at least whole numbers and decimal numbers. So I know how text is stored. I know how numbers are stored. I know how the variables are represented. I also want Boolean variables, true and false, right? Remember I said that's fundamental. I always want to know how to use Boolean variables. So logical variables, true or false variables. And then there's two other types of variables that are going to come up. And they come up because we're manipulating objects like files or windows or stuff like that. Those are objects. If you're familiar with the web, there's objects everywhere. And a handle is just basically an ID, a unique identifier for an object. So I want to sort of be able to store a handle in a variable. So sometimes it's just stored as a whole number. Sometimes it's a special type. You want to know how in that programming language we manage the sort of the handles, like the handle on the door, right? What is the handle for a file? What is the handle for a window? What is the handle for a stream? What is the handle for a web thing? So I want to know how that's managed in this language. And the last one is indirectly pointers. So I want to basically say a variable that points to something else. A variable points to a procedure. A variable points to another variable. A variable points to a program. A variable points to a person. You point to something. So that's the 5 types that I try to learn about. So when I learn a new scripting language, I try to learn and make examples of each of these variable types. For me, they're fundamental. If you wanted to break it down even further, you can skip pointers out. If you want to get further, you can skip handles. But I think that text, numbers, and Boolean without handles, you're starting to miss the accessing of files, which is also fundamental. So that's the notion of variables. So variables are part of your program. They're going to be part of your program. You're going to put things in variables, things that can change. Another notion that's important, and it's very script dependent, is data. Now, there's 2 types of data that I have to know how it's handled. One is persistent data. Persistent data is data that's going to live there after I'm finished, after my script runs. That data is going to stay there forever. So it's probably saved in a file or a database or something like that, or printed out. And data can be transient. Transient data is just good while the script is running. And sometimes it's just good while a part of your script is running. So you've got to really understand, how does transient data work? How does persistent data work? This is different in each programming language, and it varies dramatically. And it could make, you can have a script that looks like it's perfect, but because the data is transient, every time it's run, the variable is different. So it doesn't always remember what the last time it was. Sometimes it starts always at 0. Sometimes it starts arbitrarily. So this is a very important concept. So data also has form. The form of data is important if you're going to manipulate data, and there's a bunch of forms. The raw ones are text and what I call CSV, which is common separated variable. I use this a lot, but today we're using JSON and a lot XML. Depending what world you're in, there's databases and raw files, binary files. There's all sorts of ways the same exact data can be represented. Don't believe for a minute that this is the same for every scripting language. The data form is the same, but how you put it in the form and get it from that form is important. And the key thing is, when the data is in that form, you got to move it into a program variable, manipulate it, and put it back into the form. So it's important to understand the form and then how you get things in and out of the form. So what are the operations we need to know how to do? Well, the operations, the data operations I want to learn for my scripting language, depending on the form. So you pick the form. Like, let's say you say, I want to be able to work with JSON objects. Fine. So you need to basically learn how to create a JSON object. How do you do that in the scripting language? You learn how to read a JSON object, how to update, how to delete, how to save, how to restore, how to reset. All of these are the fundamental operations on any type of data. Any type of data. It doesn't matter what the form is. You need to be able to create, read, update, delete, save, restore, reset. Those are 7 fundamental basic data operations. So you need to know both the programming language or the scripting language and the form. Now I don't think you should memorize all this stuff. I think you should learn how to learn these things. So you start with something that's relevant to you, that's important, and in your scripting language, learn and make it fundamental. Like, learn and basically simple things, but they're not complex. Usually there's libraries that help you, but these are the things that I have to learn here for the form. Every form would be different. The 7th step, almost at the end of my steps, is the notion of a file system. The file system is how the computer organizes data on storage volumes, like hard disks We used to put it on magnetic tapes. Files, directories, so how things are stored in files and directories. This for me is very important. If I'm writing a script, the script's going to live in a file. It's going to read information from a file, put information into a file. We have to be able to create files, manipulate files. I've seen people who don't understand file systems trying to write scripts, and they're lost. So you have to really understand the basic file system that you're going to be working with. And when you have files, the files don't just have data. They also have rights. So not everybody can open or change every file. Not every file can be executed. So we have to take a deep look at the actions and rights of files. And also files are an abstraction. What is a file? Varies a lot. Sometimes a file is actually a stream of information. And we look at the word streaming today, streaming. And I just remember so well when I first learned of streaming, and it was in about 83 that I started working with streaming. And today I love the fact that, like, my grandkids talk about streaming. You know, streaming used to be a very complicated technical concept, and now it's like, hey, we take it for granted that we know how to stream. Well, a stream is like a file, and so you have a file system of streams. So these are all things that you're going to be manipulating and using in your scripting language. So learn the file systems, the basic operations. How do I learn these things? So I just gave you a list of the things I want to learn. I collect Fieldstones. Fieldstones. This is a beautiful, beautiful method. I learned it a long time ago, but it wasn't until Jerry Weinberg published the book, The Fieldstone Method of Writing, that I could finally have a name for it. So yes, this is what I've always done since I started as a kid. I've got a box of index cards from the 1970s on my shelf behind me here of basically nuggets of knowledge, nuggets of information. When I learn something, I basically save it as a nugget. Now this what Weinberg calls a fieldstone is a metaphor. In a lot of the world, especially where I live, historically, people have built houses from stones that were actually from a field, not from a quarry, from a field. And the farmers or the people who lived there would basically find stones, and when they found an interesting stone, they would save it. And they would save the stone, and then eventually they have all the stones, they build a house with the stone. And some stones were good for the fireplace, some were good for the front, some were good for the back, some were good for the roof, some were good for the foundation, some were good for the steps. The stones might have had different purposes, but they were collected as they were discovered. And the farmer was always looking for stones. So as I'm learning my scripting language, I basically create little teeny weeny baby scripts, and they become my fieldstones. And I save them, my little fieldstones, and they're little examples of how to open a file, of how to read a JSON object, of how to do all of these things, just teeny weeny little scripts. So as I'm learning, I'm not just memorizing to pass a test. I'm building my own personal collection of small examples that implement all of the basic operations I'm trying to learn. And they're small, little independent atomic examples that are going to be my exemplars. They're not, and it's not for instruction of the whole world, they're just for me. They're not general purpose, but they're capturing what I learn. So as I learn more, I have a bigger and bigger collection of these fieldstones. And in fact, if you look at the directory I put the examples today in, it's basically a collection of fieldstones. I call it fieldstones. So this is my technique. Now, before I show you my closing example, I just want to make my final parting comments. So when I'm talking about scripting here, I'm not talking about scripting to save the world here. I'm talking about scripting to add value. I'm talking about scripting to get your job done. So I believe it's very important while we're doing exploration and exploratory testing to use scripts. They're powerful tools. You should really benefit a lot from them. But I want my scripts to be good enough to do the job, but they don't have to be super. All scripts do not have to be maintainable forever. I make it for the job at hand. Once the job is done, I move on. Sure, I'll save it, and I might inspired from it in the future, but I don't have to maintain it forever. All scripts do not have to be for regression testing. And that's critical. There's so much emphasis in the world of automation today on all this continuous integration and automated testing in that area. And, well, guess what? That's really nice and fancy and fun. But the real learning comes from punctual scripts you create on the fly as you're going. And you're going to just find it fascinating to be able to script as you go. And those scripts can be the basis for creating regression later. Scripts should be enough to get the job done. They don't have to be super. They have to be good enough to get the job done. Sure, they have to be trustworthy, but only in as much as your job is concerned. So it works on your computer at your time, in your environment, with your data. It doesn't have to work in 3 weeks from now. It works now because you're doing the job now. You're learning now. And scripts, for me, they support my testing. They do not replace testers. Do not ask me to give you a lecture on return on investment of scripting. That's not what we're talking about. I'm talking about enabling. I'm talking about enabling your ability to see, observe, control, manipulate, and basically get things done. Now, that's the end of my little deck, but I really want to walk you through this little example. So I put this example together. It's called keyword-driven testing. It's a script. It's a pretty common pattern in my experience. And what I do is I get into a new environment and I have a problem to solve. I will probably create a script like this to help me do it. And I will try to whip it off relatively quickly, like minutes, not days here. So the script basically's job is to basically parse a file. And the file it parses has a bunch of instructions. And the first word in each instruction, the first word is an action. So it tries to tell it to do something. And I parse it. There's action and data, sometimes the expected outcome. The script reads the data source one line at a time, controls the system under test, reads the result, and logs the result. So you read from the input, you control the system, log the output, read input, control system, log output, and continue in this loop until you've exhausted the input. So that's the pattern of keyword-driven test automation. I already showed you the what is it called? The flowchart for that. So I made this flowchart to look at it carefully. You have to walk through it, but basically what this does is it takes the input file, puts it into an output repository. It saves the input file in the repository. So every time you run it, it creates a new repository. Every time I run the script, I create a new repository. Then I read the manifest. I go through it one line at a time, one record at a time. And I basically say, okay, is there an error? Something happens. Otherwise, I look at what's called the keyword. It's the first line of the first word of the record. And if it's the word launch, I launch the software. If it's a keyword action, I do some sort of action. If it's close, I close it. If it's end, I end the terminant. Otherwise, I do nothing. That little flowchart, that's it. One page. It's not complex. And I'm not saying I can do this while I sleep, but I ask you, you have to understand how to create that, look at it. It's not too complex, but almost everything I talked about is in here. So what does the script become? Well, if I can show you the source code of the script, let me just take this, move this over here. One to work with 5 windows. So the script is called try.action. Try action. It's written in Python. The beginning, a little bit of overhead at the top. So all this stuff at the beginning up to line 42, that's just overhead to basically get ready, make sure you have the information you need, the data you need. At the beginning here, I have a little bit of text to give me a string. So I'm going to put a string together, which has a unique string based on the date and time up into, I believe it's milliseconds that I'm doing this. So every time I run it, that string is going to be different because it's a different time it's run at. I create a directory name based on the string. So I create a directory name. Then I create the directory. That's how you create a directory with Python. That line 51 I learned is how you create a directory with Python. New directory is a string variable. os.makeDart with the string, and it creates the directory. It's really cool. Then I basically get my input. That's the data source, manifest. So I basically copy the file. That's how you copy a file. Trivial. It's almost simpler than using Windows Explorer. Change directory to the new directory I created. So I'm going to run the script in that directory. Let's see. Get the current working directory. And then I'm opening the manifest. That's the data source. Opening it, and I'm reading it one line at a time. This is the format of it. It's CSV. So I'm reading it. I use a tool, CSV Writer. This tool will help me write CSV files. That's my log. And it will help me read CSV files. So I basically have a tool and a library that I use to help read and write CSV files. The format described here in commentary. Let's see, parse the keyword. So I look at, is it launch? Remember the one in my flowchart? This is the code. This little bit of code here launches a Windows application. That's what it's doing. It takes the name of it in text and it runs the program. And then it waits for the window to be active by looking at to see is the window there. So that's how you see if Window's there. That's the handle stuff I talked about. And then if there's a word action, well, in this case, we're doing a program that computes the type of triangle. So it basically makes sure the window is active. So make sure the window is active and then simulate keystrokes. So this is output. This is simulating keystrokes. So it's output from my script, but it's input to the application. So I put, simulate typing, and then this is, if I close and finish, simple stuff. And in the end here, a little bit of management for the log files to make sure they're closed robustly at the end of the script. So when this script goes, it basically creates a directory and it does the job. Now, if I can show you the thing running, I'm not sure if this is going to work here. Let's try that. Not that one. Not that one. That one. Now, this is always funny when I'm doing a presentation to see if I can actually get this running here. So we'll see if it works. If it doesn't work, you try it at home. I don't guarantee it's terribly robust. It sort of works on my machine. It takes a few minutes to get started here. Hello, script. Do something. Don't embarrass me, script. There it is. It's running my little program. That's an implementation of Glenford Mayer's triangle program. So you give an A, B, and C. It tries different variables. So I will be able to try. I can try 10,000 cases in a few minutes with that script. It's just beautiful. And it's simple, trivial little script put together as I was learning notions. I had no idea before I wrote the script how to open files, how to manage a CSV, how to do all that stuff I shared with you. I learned it on the fly here, and I created the script basically from the flowchart. So the flowchart is independent of the technology. So when I wrote the flowchart, I had no idea how Python could make sure the right window was active. I had no idea how to type in values into a screen, and that ran. Now, if I look at the file system that it created, and let me see here. So Fieldstones, I'm going to have to move this to the right window. Bear with me. So you'll see that every time it runs the script, it creates a new directory. That's the directories it creates. So this is the newest one here now. Where is it? 20U21. 1. If I do date modified here. 123. So that's the output file. And if you look in there, it has, for every test case, it has an output. And it has a log of all the outputs, and it has the input manifest. And if I just want to show you what that manifest looks like, just show you how trivial this is, I will show you this is not rocket science here. It's just in a spreadsheet saved as CSV format. That's it. That's all. It's basically one column is a identifier. So I like to have a unique ID. I'm big on tracing. So I have a big ID, the action, then the value for A, B, and C, and that's it. Trivial thing. You can have any number of columns, do whatever you want, and you just file in Excel. You say file, save as, and I'm not sure where the type is here, but here's the type, and you can save as what's called the CSV format. CSV format, that's it. Very common data interchange format. I'm not going to modify anything here. I have another script that I created as part of the preparation for this exercise, which is a cool script that runs in the background, just to show you what it looks like. Let's see here. So this is called mess. It's 20 lines, including comments. What it does is it gives me a message, but it gives me a message in the background. For me, this is very important. Can I run a script in the background? And I can, if I run a script in the background, while it's running, it can monitor stuff. Like it can wait for something to change. It can wait for someone to log in. It can wait for a record in the database to change. It can wait for you not to have enough memory. It can wait for, so you write a script that watches the system and waits for something and then sends you a message saying, hey, Rob, this happened. And this is instantiated This is how you run it. It's 2 lines to run it. And this to me is a real complex thing that you can do relatively simply to do what I call the type of scripting are basically probes, right? We're doing probes like in Star Wars, right? It's probes, waiting to see who's on what planet, etc. I'm not sure if I'm back to a normal view now, but that was my presentation. Sorry it ran a little long. Mahesh, are you there?
Yeah, I'm here. So that was amazing. And yeah, you are back to the normal view now.
Thank you.
I learned quite a few new things, like CRUD++ was one of the things that then, while we open it up, for questions from the audience,
Absolutely.
one quick question, like when you say you collect the small nuggets of information and then you store it, right? But at times it might happen that you have just your laptop, at times you just have a diary and a pen. So how do you store them? Like you store them again into one particular format and a place, or it all goes on paper?
No. I'm old, gray hair. Right? I've been using index cards since the 1970s, and I basically put my little nuggets on an index card. And these are pretty big index cards, right? But I usually use index cards of that size that fit in my pocket. Now, I used to be a smoker, so it was in my pocket like a deck of cigarettes. Today, I have a cell phone, and it fits in my cell phone, right? Like that. So my cards, so I don't want to lose my cards. My cards are precious. And when I get a nugget, I want it to be that size. Now, of course, technically, when you're using a computer, I basically would create a directory and put them in a file system, basically a simple file system, and I might basically organize it hierarchically based on like input, output, CSV files, JSON files, etc. And I really want them to be independent, like little scripts that are just doing one little thing, not doing everything. Like here's how to copy a file. Here's how to print an error message. Here's how to check if it's a window. Here's how to launch a process. Just little things. Like I said, Fieldstones. And once you got that Fieldstone will be fulfilling a purpose later. But I don't try to create a general purpose library. There's so many people in the world of test automation that try to tell you create your reusable libraries, and all of that is about dropping the maintenance cost of regression testing, which is important. I'm not saying that's not important, but that's not the type of scripting I'm talking about here. I want to do useful scripting to do really freaking good testing. So maybe my script will be useful, right? Maybe.
Before we open it up to the audience questions, how many index cards you must be having so far?
How many what?
The index cards which you store or you write on? Like
I have thousands.
Oh.
I have thousands.
And you go back to the older cards every now and then, or it is like need?
I have because of COVID. Yes, this last year I've gone through some very old cards, and it's been very instructive. But my newer stuff is all in files. I mean, I create text files, But the cards, I go through old ones. I recently went through some old ones, literally from a project I did that was in about 1979. A device driver that I wrote for a PDP-11 computer, and I was reviewing methods in that because right now I'm concerned with trustworthiness of hardware, and I had some really cool stuff I did in that area, and the cards were a really helpful refresher for me.
Okay, nice. Thank you.
It's Fieldstone.
Thanks again. It was wonderful, the session and these answers as well. Let's move to questions now. So if you see the questions tab, I see one by Ajay so far.
I'm looking at the chat tab. Sorry, I was looking at the wrong tab.
Below the chat, there should be questions tab.
I see. So what language do you prefer to use in scripting in data migration testing projects, and how do you choose them? The last major data migration project I did, I was using Perl scripts, and I chose it because at the time it was technically appropriate. it fit into the environment that I'm working on. So I would look at the environment you're working on. I would also look at your team, and I would choose a language that you're not the only person in the team who knows. But for data migration testing, today also the libraries in Python are just out of this world. So if you have some flexibility, data migration, I've been looking at the libraries. They're fantastic in Python. I don't have hands-on experience. Most of my stuff in that area was with Perl, but at the time that made sense. It was the team was using that sort of technology, and that was appropriate. Today, I don't want to ever tell you there's a general language that's perfect for data migration testing. There's a scripting language for you for sure, and on any given project it might be different. But for you, probably you want to look at the team and see the language that's close to what they're doing. Now, if everybody's using JavaScript, you can do it with JavaScript. Even though JavaScript is used for GUI interface stuff, you can do a lot. There's beautiful stuff you can do with it. But pick a language that you're not the only one in the team using. That's going to help you a lot. I don't know if that helps. Hi, Rob. You're really a master of creating tiny, useful utilities. What do you credit most of your sense of discovering opportunities for utilities? Wow, that's a beautiful question. You want the attribution to credit? It has to be the way that Dennis Ritchie and Kernighan decided to teach the C programming language. That was a sensibility. But I was encouraged. I mean, there was a teacher I had called Mr. Moss, who in grade 6, like this is late 60s. I remember distinctly he had us take index cards and write notes on them. And it's like, that was just how I learned how to do it when I was very, very young. And through high school, I kept doing it. I freaked people out sometimes with my index cards. So I picked it up very young. And maybe it comes from the Unix world, the early days of Unix, the conceptual models, the simplicity of it, the fact that every single utility was a basic function. And one of my mentors was Dr. Peter Sylvester. He was my mentor, and he was one of the first people ever to write a book explaining how to use Unix to people who were like non-programmers. It was fascinating stuff. This dates back to like early 80s that he wrote this book. So I was really exposed to a lot of the whole idea of everything is a sort of a small little chunk. And Weinberg just gave me the beautiful words to describe it with the Fieldstone. But that's my answer. That's the origin story.
That's nice. So all these utilities stay on your local machine, or I'm just wondering, like someone in probably in today's time, if has all these many utilities, and if they put it on their GitHub repo, what kind of online portfolio they'll have? And
well, you think about it, because if you like, for me, that's what the word you just said is, portfolio, right? The portfolio is all of the things you can do. It's more important that I can do something. Like if you ask me, do you know Python? I say, well, here's what I can do with Python. Not, am I a master Python? I'm far from a master Python. Are you kidding? There's a lot of things I can't do, but here's some really cool things I can do that are probably really useful for testing.
Yeah.
And so that's what you said, a portfolio. I like that. And your Fieldstones can become that portfolio. Why not? That's a good idea. We should explore that. That's cool. We just got to trick the HR people into asking those questions.
Yeah.
I can't see any other questions.
There is one by Jan.
I don't see it. It's funny. I see 2 questions.
Do it.
Oh, there it is.
Yeah.
In light of Maven and Gradle and CI stuff, are we in danger of overscripting? Yeah, that's a real risk. I have to tell you, I see that a lot, and probably more than you can imagine, right? So think about the space I'm in. When I'm working at the university, I have about 200 students. And each student, I have them do research projects, and they're very specific. So we're going to be doing interviews. We interview real people. So I get a lot of information, insights into what's going on. And I see really basically too much emphasis on the CI DevOps chains. And yes, that's a lot of scripting going on there, but people are basically trusting it. And that trusting is basically like saying, I trust this software. Well, who's testing the scripts, right? Who's testing all these things? So scripting is important for those environments, and it's important for CI, it's important for CD, it's important for those tool sets. But yes, there's an overdependence on them, and there's encouragement by the industry and the vendors to push that and promote that and over-trivialize it. So I would suggest that in that world, in the world of deployment and building and regression testing, there's probably the need for discussion of robust scripting, and to decouple that a little bit from what I'm talking about is useful utility scripting. So if I wanted to create a robust script, I would treat it just like a software project, and I would have to have requirements and design and architecture and robustness and testing as part of the development of it. It's sad when I see a build system for a complex piece of software that's basically with a very weak script that doesn't take into account the possibility that the file system is full, or they don't have the privilege when they put a file somewhere, and suddenly all the transactions die. That very bug I just described, I saw for the biggest mutual fund clearinghouse in North America, which was moving $200 million of assets every night, and it was blocked because of sloppy scripting. So yes, there's an over-dependence on it. If we are going to depend on it for the CI/CD thing, I think it's very important to treat those scripts as basically objects that we're creating just like any other software project, if that answers your question. It's very important. Question here, I think, is this, how do you organize your index cards? Do you use tagging? Now I do tagging. I did tagging since 2005 about. Hierarchies never. I hate hierarchies. I want to discover hierarchies but not create them, so I use mind maps a lot, mind mapping concepts, but I don't create a hierarchy and fit everything in. So many of my customers say, hey, Rob, what's your hierarchy? And I say, no. I discover my hierarchy. And the hierarchy is going to change, so I like to make it volatile. But tagging, I love. I love to tag things. And in fact, tagging in index cards works very well. And in fact, I use Avery stickers. And this is right here, for example. So I have thousands and thousands of Avery stickers, and I put text on and pictures on Avery stickers, or color code them, and I stick them on index cards. And that's exactly tagging, like putting hashtags in your files. So I love doing that. I'm a big tagger. I'm against trying to prescribe a hierarchy, but I'm big on discovering hierarchies as part of your modeling, mind maps. So mind maps, every time you enter a node in it, you got to refactor it a little bit and move things around, shuffle things around. So mind maps are about the relationship between objects, and that's what I like. But in terms of the physical cards, tags all the way. That answer the question? I hope it answered the question. Next one. I love your passion and approach. This is the first time I have heard anyone approaching scripting from the foundations. I heard recently that Python is one of the most important scripting languages. Would it be a good one to start with? I think you should just have fun. I think Python is fun to learn, and you'll have fun. I mean, I love the fact that, my granddaughter, when she was like 8 years old, started learning Python, and that's so cool. It's so cool. I can imagine, so people of all ages. Python is just fun, but don't get caught up on it. Do practical things with it. If you have an ambition, one cool thing about Python is now it's a scripting language, but it's being used by mainstream programming, and it's espoused by the world of AI, and it's espoused by the world of big data. It's incredible. So yeah, sure, have fun with it, but don't lock yourself in and say, I have to get a certification in Python or something like that. I think it's doing useful things and building your Fieldstones. It's great if you have the choice. Still, punishment, it's got to suit the crime, right? The punishment suits the crime. You've got to choose the scripting language to solve your problem. Look at the context. Look at the business, the technical, the organizational, and the cultural factors to help choose an appropriate one for a commercial project. Because I don't want you to be alone in isolation. I want you to use something that you can collaborate with other people on. So if you're the only one using Python and everyone else is using Ruby, you're probably better in that team, in that context, to muck with Ruby, just for a practical collaboration perspective. Looking forward to boot camp. What can we prepare to be ready? That's a good question. Wow, that's a good question. Prepare. Well, I think that if you want, I can send you a book to read, Mahesh. Maybe you can share it with people who sign up in advance.
Yeah, sure.
So I have a book I wrote called Charting the Course, coming up with great test ideas just in time. I think refreshing your de bono, lateral thinking, might be a good start. And that's about open mind. Maybe come in there with a couple of recent problems that we might be able to use in some of the exercises. But I can definitely give you some reading material if you have some time. I'm not opposed to that. In terms of preparations, open-mindedness, right? Zen. Be ready. Spend all those hours with me. I don't know how much time you can take with me. You're going to go nuts after a few hours, but it'll be fun. We're going to do a lot of good stuff.
Awesome. Let me just quickly check if anything we have on YouTube or Facebook. I don't see anything there. So yeah, we look good for today, Rob. And
Beautiful. That was wonderful. Thank you so much.
Thanks to you. And I hope we haven't taken any more time from your fishing schedule.
Oh, I've got to get out there fishing, but my son is already on the water. He probably already caught a fish, and he's going to brag about it to me. But that's okay. No, I'm going to be going out there on the Ottawa River. If you want to check it out in Google Maps, near the town of Rigaud, Quebec. We actually have the ice is so thick we can drive out onto the ice, and we're fishing today with 20 holes on the ice. And last week we did some fishing and we caught a whole bunch of pike, northern pike, and beautiful perch. And it's really, really something that I love. And I plan on writing more about how fishing and testing all fits in together so that I can justify my fishing as a business expense.
Wow, nice. And what temperature it is there? Like some -22, you said?
Right now, we're hovering around -15. Hovering around on the water with the wind, it'll be -20.
Okay, nice.
I am wearing right now 3 levels of undergarments, long johns, shirts. I am dressed for this.
So these are very alien things for us in India.
But oh no, you've got to do ice fishing in India. It's great. I'm going to go there. I'm going to teach everybody how to do ice fishing in India. It's going to be cool.
Great. Okay then, so we won't take any more time from your schedule. Thanks again for joining us today. It was wonderful having you. And see you again at the boot camp.
And whenever you need a webinar or something, glad to help. Take care, guys.
And thanks everyone for joining, taking time from your Saturday schedule. Goodbye. Have a nice weekend ahead. Thank you. Bye.
All right. Thanks. So I'll just log off then. Take care.
Yeah. Thank you. Thanks, Rob. Bye.
I'll send you the files tomorrow.
Yeah, sure. I'll send them across.